Hi everyone, welcome to Brilliant Qatar. Ohms Law. It's a very important law there in electricity. And it gives us the relationship between electric current and electric potential difference. Today, in this session, we are going to study this Ohms Law. So, just we can begin by remembering what actually this electric current means. So, what is electric current? Electric current simply is a flow of electric charges, and numerically it is a time rate of flow of electric charge. So we can represent the intensity of electric current by I. So we can write I is equal to charge over time, or it's equal to Q over T, where Q is a total charge, the symbol of the total charge, and T is a time for which the current is maintained through the circuit. The unit of electric current is ampere and the symbol is capital A. And how we can be to define 1 ampere means? Is 1 ampere is that much current developed when 1 coulomb charge is flowing through any circuit in 1 second. I hope now you are remembering about what actually this electric current means. Now we can recall what actually this potential difference means. Because Ohm's law gives us the clear relationship between what electric current and potential difference. Now we can come to what is potential difference. Its potential difference means it is the amount of work done in moving a unit charge from one point to other point in a conductor or in a circuit. So what it is? It is the work done in moving a unit charge from one point to another there inside a conductor or in a circuit is what we call its potential difference. The potential difference is also be a measurable quantity. It can be measured with a unit or called volt. And it is otherwise, it's colloquially known as, the potential difference is colloquially known as voltage. It's also known as voltage. And the potential difference or voltage can be calculated by a numerical formula. It's equal to work done over charge. Work done over charge. So the work done we can be represented by W and the charge by Q. So we can write an expression for finding the potential difference in a circuit is equal to W over Q. I hope you understood this potential difference and this electric current well. Now, we want to study about what do you mean by this 1 volt potential difference. That also we can remember that. So, what is 1 volt potential difference, or how we can say a 1 volt potential difference is applied across the two ends of a conductor? See, 1 volt is the potential difference between any 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to other. So, inside a conductor, if you want to move a 1 coulomb of charge from one point to another, and if you are doing a 1 joule of work, then definitely we can say the potential difference between the 2 points is said to be 1 volt. So, 1 volt is the potential difference between any 2 points inside a conductor when 1 coulomb of charge is moving from one point to another by doing a work of 1 joule. Clear? And now, the potential difference is a cause of electric current. That means, if you want to maintain an electric current, what we indeed, potential difference is indeed in every circuits. So, mainly in most of the DC circuits, see, the cell is a device that which helps to maintain the potential difference inside the circuits. So, in every circuits, if you want to maintain a continuous flow of charge, we should maintain a constant potential difference. And the potential difference usually in DC circuits, it's maintained by connecting it with a device called cell. So, the cell is a device which is used to maintain the potential difference inside the circuits. Now, I already see what our main topic is, we want to study the Ohm's law. I already mentioned Ohm's law gives the connection between intensity of electric current and the potential difference inside the circuit. So, I will explain this Ohm's law with a diagram there itself. We can see that one, right? So, for that, I am drawing a diagram here itself. Now, we are taking the case of a water tank that which connected with a pipeline, and the end of that pipeline, now we are connecting with what? A tap. just with the help of this water tank and this pipeline, we can try to learn or to understand the concept of this Ohm's law well. I hope through this example, everybody will get a clear idea about this Ohm's law. We can see. Now you can see, I just replaced a stand over there itself, you can see, and over this stand itself, I just replaced a water tank, that also you can see, and from the water tank itself, I just connected a pipeline like this, and at the end of this pipeline, now you can see, I connected a tap, water tap. Now, I am asking some questions. Through that questions, we can try to study that concept of Ohm's law. Now, see, in this tank, initially there is no water. Now, if I am opening this tap fully, what I will get there? Definitely, everybody know that without the water there inside the tank, if you are opening the tap, nothing will come, right? We will not get the water, right? But now, what we are doing is, I'm going to fill, see, this much quantity of, or this much level of this tank, I am filling with some water. Okay? Now, as I am filling this much level of the tank with this less level of water, so now if we are, see, if I am opening the tap, so what I will get? I will get some water, right? I will get some water there itself. So what should be the flow rate of that water in this tape? See, definitely we know that if the level of the water in this tank, the water flow through the tap will be very less, right? Now what I am doing is, now I am going to fill up to this level of this tank. Our tank now I am filling with this water. And again, I am doing the same experiment by opening the tap right now. So now can you say how much will be the water flow rate there? See, now we can see that more water will be come out from there, right? Right? So if the water level, so now can you say what actually determines the flow rate of or water flow rate here? Definitely, it is very clear, right? What it is? The level difference. Once the level of the water inside the tank was very less, then we got only a feeble amount of current, right? Right? And then if the level of the water was more there itself, now we can see that the water flow is more. So we are getting more water there, right? So can we can we compare the same concept with that of the electric flow and the electric current? Right? Electric charge flow also we can compare with the same analogy. We can apply the same concept. We can also be applied there on the electric current also. So here, can I replace this water current? See, flow of anything we can represent by using a technical term. What? It's current, right? The flow of water, can I replace with this word current? Right? And this level difference. Now I am using another analogous. See, analogous to this water difference, water level difference. Now I am making with a new term. That's nothing. It is our potential difference. It is our potential difference. So now the potential difference I take from the level difference of the water and the current. Now I am taking from the flow of water. It's clear now. So now we can make the current is analogues to the water flow and the potential difference is analogues to the water level difference inside the tank. Now again we can come back to our theme. See what actually it is. Water level means here we already understood that the flow rate of the water through the tap, it's mainly depending on what? The level difference of the water, right? Once the level of the water inside the tank was less, so we got only a less amount of water. That means current was less. But when we increase the level of the water in the tank, it's more, or as we increased it, so we got more current or more water flow we got there. That means at that time, current is become more. So how we can be to see relate the water level difference with the water flow? It is exactly clear, right? If the level difference is increasing, the flow rate is also increases. If the level difference means is decreasing, then the current flow also or the water flow also decreasing. Now I told you here the water level difference we just change with the potential difference and the water flow with the current in the electrical circuit. Now, how we can be to relate both the potential difference with that of the current? Yes, it is very clear. So, we can be to write the potential difference. Instead of this potential difference, I am using the symbol. What is the symbol we are used for representing the potential difference? It's V. And what is the symbol we are using to represent the current? It is I. So, now I am using these two letters. I am correlating both. Now, it is very clear. I already, at the beginning itself, I mentioned that even there inside our water tank, if there is no water, it's present at the beginning, right? At that time, when I opened the tap, I did not get even a single drop of water. So it is very clear, if you want to get the current or if you want to get the water, there should be a water difference or water level difference or water should be there inside the tank. It is clear now? So from that itself, it is very clear that in every electrical circuits, if you want to maintain the current, what should be there? The potential difference should be there. If only potential difference inside the circuit, then only we can maintain what? The electric current. So, we can relate both the V and I like this. What we learned from this example, see, we can say that the potential difference V is proportionate to what? This I. Is it clear now? I hope that you understood this concept well. See how when we are relating this potential difference with the current, we can see that the potential difference is more, then the current is more. If the potential difference is less, the current is less. So, how we can be to relate both potential difference and current? Its potential difference is directly proportional to the current I. Is it clear now? So, just we got an expression just like this, right? Just we can be to avoid the proportionality. I need a mathematical expression. So, how we can be to correlate that one itself? We can write V is equal to a constant into I. So, here we are taking the constant as R. That's nothing. It is a resistance offered by the conductor against the flow of current. So, here R is called the constant of proportionality and it is always known as to be the resistance. So, this is a relationship that's trying to say through this Ohm's law. This concept was first of all put forth by the eminent scientist George Simon Ohm. Just we can learn the statement of this Ohm's law, right? So, what Ohm's law says? The potential difference across the ends of a resistor is directly proportional to the current that which flowing through it, given that or provided that the temperature remains the same. As you are keeping the temperature of the conductor, the ends of or through the conductor is keeping the same. Now we can see that the intensity of the current that which passing through the conductor is directly proportional to the potential difference applied across its both ends. And this statement is what we call the Ohm's law. And mathematically, we can relate both the things as V is proportionate to I or V by I is equal to a constant, and that constant is nothing, it is what we call the resistance of the conductor. Resistance means what? It is a hindrance or the opposition that which created by the conductor against the free flow of electric charges through them. Such a hindrance is what we named as resistance. So, we can make an expression like this for the potential difference and the current. So, the interrelationship between the potential difference and current, we can be made like this. V is equal to I into R, where V is the potential difference and I is a current that which maintained through the circuit, and R is a resistance offered by the conductor. So, it is very clear that, and resistance I already mentioned. Resistance means it is a hindrance or the opposition that which created by the conductor against the free flow of electric charges through them. And it is also be a measurable quantity and it is usually be measured in ohm. And the symbol used to represent that means a unit of resistance is omega. Now we can see that it's a Greek symbol. This Greek symbol is usually used to represent the symbol of what? The unit of resistance. So don't forget. So the voltage and the current both are related with in this way. That means the potential difference is always be proportionate to the current that which passing through the conductor. It's clear now? Keeping temperature and other parameters keeping constant. This is a statement of the Ohm's law. Now I hope that all of you understood the concept of Ohm's law very clearly. If you got that concept very clearly, we can do some numerical questions using this relationship V is equal to IR. So this is the first question now I am giving you from this Ohm's law. Now everybody can see that what is the question here it is given, what is the voltage in the circuit. Now we can see a circuit here, right? In this circuit, an electric lamp and a cell is connected there itself, and both are connected with some connecting wires are there. So the question what it is given here it is, we want to find out the voltage. So from the diagram itself, what are the data they given? They are given the resistance value given, and also the current that which passing through the circuit also mentioned over there. So I will collect down, means I will write down the data given here in this question. So here R value it is given by R is equal to 8 ohm. Yes, we can write. And what is the value of the current? It is mentioned here itself. The current value which is given by, it's 5 ampere, right? Now, just we want to find out what? We want to find out the value of this voltage or the potential difference applied across the ends of this resistor. So now how we can be to find out? We have already learned that from Ohm's law, we already understood the relationship between the potential difference and the current and the resistance, how they are related. By the mathematical expression, we can use this V is equal to IR formula. We can find out very easily the value of this potential difference of the cell in the circuit, right? So what is this value of I? Now we can substitute the values of I and R in this expression. See, I is equal to how much? I is equal to 5 amperes and it's equal to 5 into, what is the resistance here it is given? It is given by 8 ohm. So we can be to substitute the magnitude of that resistance here as 8 ohm. So 5 ampere and it's 8 ohm. So we will get 8 into 5. 8 into 5 is equal to how much? It's 40. It's 40 volt, because volt is a SI unit for measuring this potential difference. So here from this diagram, the potential difference is given by how much? It's equal to 40 volt. Clear? I hope you understood this problem well. How to use this Ohm's law equation or the mathematical expression, how we can be to make use to solve this problem. Right. If you understood this one, we can take another question. So what is the next one? What is the current in this circuit? Just we want to find out the current in the circuit. Here the resistance of the bulb and the potential difference are given. We can calculate how we can find out that one. For every numerical question, the first step is we should try to read the question and try to understand the concept what it is given there. After understanding, the second step is the data collection. We should collect the data. What are the data it is given there itself? They are mentioned here. They are given by the given values. Given what it is? Given R. The resistance value is given by R is equal to 6 ohm. Right? And the potential difference here it is given by 12 volt. Just what we want to find out? The current through the circuit that we want to find out here. So we want to find out here the value of I. So by using these three terms, how we can find out? For that, here we can use a mathematical equation. Which formula here we can use? Here we can use the Ohm's law formula. What it is? It's equal to V is equal to IR. From that, what we want to find out here? I. So for that, we want to make an expression for I first. So we can write a formula for I as I is equal to V over R. Now can we substitute these values given? Definitely, we can substitute all these values in this mathematical expression. So what you will get then? So instead of V is how much here? V is equal to 12 volt. And resistance is given by 6 ohm. So it's 12 volt and it is 6 ohm. So by solving this, 6 and 12, we can be to cancel each other, right? So how much you will get? I will get 2. 6 will be having 2 times therein 12. So I will get the value of current, right? What is the SI unit for representing the unit of current? It's nothing, it's ampere. So I will write the unit as 2 amperes. So now in this question, I got the value as 2 ampere. In the first question, what we learned there itself, there we find out the potential difference by using the values of resistance and current. In the second question, what we find out here, by using the value of resistance and the potential difference, we already find out the value of current. Right? Now, I will give you one more question. See, in this question, see what we want to find out. Here the third parameter. In our Ohm's law, we are discussing with the three parameters here, right? What are they? The electric current, the potential difference and the resistance. So, the first two questions, we already find out how to find out voltage and current. Separately, how we can be to find out using this Ohm's law formula, right? Now, here we are in this third question. Now, we are going to find out the value of resistance. So, now we can see that in this circuit, a 24 volt potential difference is applied across this lamp. But we don't know what is the resistance of the lamp. But they already mentioned how much is the current that which passing through the circuit. So just we can write down the data it is given. So what are the data it is given here? The given values are, see here the V, the potential difference here it is given as 24 volt. And the current value it is given by how much? 6 amperes. Now what we want to find out? We want to find out the value of this resistor. See how we can be to find out the value of this resistance. So we can use by connecting VIR. Which formula here we can take? So we can take the Ohm's law. Once again, Ohm's law, what it is saying? V is equal to what? IR. By using this formula, what we want to find out? The value of the resistance we want to find out. So we want to make an expression for resistance first. So we can make a formula like this. R is equal to what I will get then? V by I, right? Now can we substitute the values of V and I here? Definitely. So what is the value of this V? V is equal to 24 volt. And what is the value of I? I is given by 6 amps. So how many times the 6 will be there in 24? It's definitely everybody know that one. It's 4 times will be there. Right? So, volt per ampere, that is a unit for what? It's a resistance. So, what is the SI unit for measuring the resistance or representing the resistance? It's nothing, it is ohm. So, we can write 4 ohm is a resistance of this bulb. Now, we got the value of the resistance of the bulb as 4 ohm. Now, through these 3 different numerical questions, we just try to understand how to make or how to find out voltage, current and resistance separately in certain numerical questions, right? Now I hope that you understood the concept of this Ohm's law well and you understood how to find out the values of electric current, potential difference and the resistance in simple electrical circuits. We can see with a new topic in the next video. Till then, stay safe, stay healthy.